Hello everyone. We will wait for a few minutes and then we'll start the class. Good evening everyone. We are waiting for 2 or more minutes and then we will start the class. If you are having any issues to listen my voice clearly, please mention in the comment so I can make the adjustment before we start the session, and then we can focus on our today's topic, malicious network packet analysis with Wireshark. Okay, now I am starting the session. Thank you for joining me today in the session of threat hunting, incident response and memory forensic. And today our topic is on the investigation and analysis of a malicious network packets. When we say that we are good in the network analysis or packet capture analysis, that we are directly saying that we are good in the different protocols, services, how they works, how they looks, what different headers, informations they have in the network packet that used during the analysis or investigation. As a responsible SOC analyst, the SOC team and the other person working in the SOC team should be good in the log analysis and network packet analysis, because these two things are very important for detection and identification of any suspicious or malware or anomalous activities during the review of this log and network packets. Network packets are being captured by the devices, generally by the IPS or the firewall devices, and logs are being stored by the all different devices, either it is a Windows machine, router, switches, firewall, IDS, IPS, your antivirus. So you should know first that how these different logs looks and what important information you can get it and how you can use those information with the correlation of different other attacks or in correlation of identifying the attacker IP address or attacker activity in the network. Generally, companies do not store the network packets because it takes a lot of storage to store those logs, and the store the network packets is not sometimes possible for company to store for a long time. Some companies try to store those network packets for a very limited time of period. So in case of any incident occurred, they can review those network packets and can identify and can correlate other artifacts related to that attack or activity. Network packets are very good in showing us the interaction when attacker had entered in the network and when how it copied or any exfiltration had happened. We can do the whole lot of different investigation and analysis with network packets, which are not sometimes available within the logs, because logs will show you only the capabilities which the machine has to generate on the basis of the activity. For example, if an attacker compromised a machine and added an account, then you can get a log from the machine. But if you will have the network packets, then you will not see the user account details in that network packet, because that account is actually added or created in the machine that logged by device log file. Network packets provides different information based on the protocol and communication, ports and services, and information available in their headers. For example, if I am sending a TCP packet and it has nothing, no content in that application layer, we can identify the information about the network packet, about the physical layer, MAC address, destination MAC address, about the IP layer headers, what flags it used, about the flags in the TCP header, and IP address, port details, and other different header informations which we had already covered in our book Hunt the Hackers, a complete SOC analyst guide in detail. But today we gonna show you how a network packet which is actually containing some malicious activities, how we can use that, or even you can also use in your local machine to identify the threats or exploit taking advantage of your existing vulnerabilities in your machine, or if your browser has been compromised, or if attacker compromised, because generally if you are not updating your machine, your Windows machine or any machine on time with the patches, attacker easily target those machines by putting their exploit on different malicious websites. Even you open any third websites which is hosting some different kind of films or other entertainment material content, so attackers usually store zero frame exploit in those websites. So when you open those websites, it install a backend, a different code or executables in your machine to exploit or to take advantage of any existing vulnerability, which cannot be not be seen you by looking at the window. But if you are good in the investigation, if you are good to know about the different communications, DLL libraries, services, registry modifications, then you might can identify those changes. And when you are using the antivirus, some web-based module which can also notify you and can block those malicious connections based on the detection of any signatures. Any security product, IDS, IPS firewall generates different signatures only if they have the signature. So if IDS generate an alert for SQL injection attack, that means IDS had the signature for that particular SQL injection attack. If IDS or IPS don't have the signatures, then it will not generate any signature for that as well. Now I will show you how to do a practical with the live, and how we can identify the network packets as a malicious content in that. So first of all, I'll open my Wireshark, and then I will show you how Wireshark looks. And because in my last session, in my last video, I had already mentioned about the different interfaces options we have, difference between the capture display filters. But now today we will be more practical on terms of like checking the malicious packets and using the display filters. So now let me open my Wireshark. I hope you can see my screen now. I am on the interface of the Wireshark. I just installed and opening the Wireshark now, and will show you how we can capture the network packets and how those network packets can be used in the analysis and investigation of different malicious network packets. So now I can click here. It is showing me one interface. These are the capture filters which we use generally, and we can so these are the different adapters which we used to capture the network packets. Wireshark usually shows different adapters if available in the machine. In my case, now this is the loopback traffic capture, which is not generally opening. Now let me open in my Wireshark in my other machine, so I can, without making any troubleshoot issues, or we can open directly. I will not waste time on the troubleshooting part. I will be go directly on my topics which are important for you to understand, and then we can use those different methods and techniques to identify even if our machine is compromised or not. For your knowledge and for your understanding, I can show you the different network adapter card which we can get it from the run command ncpa.cpl. It will show us the different adapters if I will present in the machines, and we can see there are different adapters already are in the net machine: Bluetooth, Ethernet. Let me enable this, and the Wi-Fi. It should be by default enabled in this Wireshark panel. If it is not getting, might be because there is an issue with the Wireshark or with the libraries, because Wireshark capturing the network package through library files, WinPcap and PCAPs, in which are taking the copies of those network packets and forwarding to the Wireshark for the further decoder and analysis. Now I'm closing this. Let me open the Wireshark again. Let's see if it is showing the Wireshark interface or not. It is not showing the Wireshark. Let me open the Wireshark with the permission admin as an administrator. Let's see if we can see some adapters or not. No. Okay. Here we can also see there are some already network packets captured we have with this Wireshark, and I'm just opening this. And I will also show you how to capture the packet in the real time with a Wireshark or T-Shark as in my session. So today's session we can cover the capturing of the network packets in the real time with the Wireshark in this, and maybe in the future session we can also cover the TCP dump and the other CLI methods which we can use to capture the network packets. So this is the already captured network packet we just opened in the Wireshark, right? So we can see there are so many packets available in the TCP, TLS. If we are not sure what are the different protocols information available when this network packet captured, we can go to the statistic, capture file property. It's capture for 15. You can see this elapsed time for this network packet is 22 minutes. That means we had run this packet capture for a long time, and how many packet total it has. We can either check in coming to the last network packet in the list pane. It has 24,678 packets, or you can directly go to the capture file property. It will also show you the other network packets captured in it. So 24,000 packet captured. And if you want to quickly, because it's difficult for all of us like to identifying the malicious activities by reviewing each network packet. So what companies do, or what we will do here in this scenario, we will run the packet captures again in an IDS or IPS solution. So we had already installed a SNORT and as an IDS in our machine, and we had some different tools in the SNORTs which are available. So we will run SNORT this packet capture against the SNORT to see if this packet contain any signatures which matches with this SNORT or not. For your understanding, let me just open the protocol hierarchy. It will show you the protocols captured in this packet capture. So we can see most of the packets are only TCP based packets, and all other, most of the 31% are on TLS. In UDP we have some DNS packets and DHCP packets also. So when initially I mentioned as well that if you are saying that you are good in the analysis and investigation with Wireshark, then you should know about each protocol and each protocol headers, which can help you to correlate the activity related to the malicious or any, if attacker have compromised your machine and communicating over the network and you have the network packet capture, then you can identify what is normal and what is not. On the basis further of that, you can identify the attacker malware file if any dropped, or attacker communication on the behalf of your analysis and investigation. So if I'm selecting the DNS as a filter, you can see now in the display filter it is showing the DNS and other DNS requests sent by the machine to the DNS server. And you also can see this is the response packet. You can see this security and response packet. How can you confirm? Just you can go in the headers, DNS header, and you can see this is asking for one question and giving some answer as well. The query sent by the DNS server is for this domain setting-win.data.microsoft.com, and you can see this is the type record A was requested by the machine. Again, that's the point for me to mention that you should go in the header analysis and about the protocols, because now we are looking in the DNS packet. That means you should know how and what contains in DNS informations and how you can use this information in your investigation analysis. This is the well-known domain, belongs to Microsoft.com. We can see here, and this is request is for the record type A. If there is a record type for any other record, for example quad A, SOA, CNAME, alias, any other records, we can investigate properly or accordingly with the observation. For a machine to send a request for a type record A and quad record A, it's very common because machines are now communicating based on the IP version 4 and IP version 6 addresses. So it is very important for you to understand the difference between the type record A and quad record A. So quad, that means there will be 4 A records. That means 4 times A will be there. I can show you that also with an example. Let me just open the CMD. We are opening the CMD, and CMD, when we opening the CMD, we can use a tool, a utility which we can use to send our DNS request to the DNS server, locally configured DNS server. Okay, now we got one question from the anomaly that in Wireshark we can only see the logs of particular machine, but in Splunk we can see all type of machine logs. Okay, again, Wireshark capturing network packets, right? Wireshark can be used to read the captured network packets. So if you have a packet capture file, you can view with the Wireshark. If you don't have that, you can create it with the Wireshark by installing in the machine. And please note, if you are installing Wireshark in that machine, Wireshark will not store the logs. It will store the network packets. There's a difference between the logs and network packets. Again, Splunk is an SIM tool. Splunk is gathering the logs from all different devices across the network. SIM engineer or SIM team responsible for forwarding those logs from different devices across the network to the SIM solution. For example, if you have a router, switches, firewall, IDS, IPS, Windows, Linux machine, SQL server, database servers, there is a requirement to configure those devices for forwarding the logs from those devices to the Splunk or any SIM solution. You mentioned about Splunk, that is the reason I'm mentioning Splunk here. So there is a requirement to configure. If you are not configured, then you will not get those logs. But Wireshark is not analyzing, is not investigating, not storing the logs. Wireshark is being used here to capture the network packets and to analyze the network packets. If you have any doubt, Anumala, please ask me. If no, then we will proceed to our class. Okay, I hope you don't have any questions now. If you have any doubt, please interrupt me in between. So before moving me forward, I can help you in the same time, because if I'm going forward and you are not understanding it well, then there is no point for me to going forward. Okay, the next question asked by Megha Sai: how can the packets be stored in the Wireshark? It's very simple. To show you the network packets capturing, let me now just now let me open my another session of like my another lab session where I can show you how to store network packet capture. Okay, now this is my another machine where I'm running Wireshark, and I have run a different network packet captures analysis already over there, but I will show you how to use the Wireshark for this storing the network packet and how to capture network packet in real time. So, and you can see in these different capture filters here in the downside, there are different network adapters already in the machine, and those there, this is the spike you are seeing. This is for the network packets. So if I'm clicking on the Wi-Fi 3 network adapters, it will show me all the connections which are being sent and received by this machine. I hope you can see now this machine start capturing. Now we have opened the Wireshark for a particular network adapters. All the network packets sent being forward and received by the adapters are being captured by the Wireshark now through the libraries function, which are taking the copies of those network packets and storing and giving to the Wireshark. Now, because you can see in just few seconds it has captured like more than 3000 packets, and it will require big storage to store these logs also, because there most of the communications are legitimate. Even if your machine is in internet, it's very obvious to send the machine for update request for different application. For example, your even Microsoft Windows, your machine, your application you installed, they look for the update patches or they communicate to the servers. Now I'm stopping this file here by clicking on the red icon. Now we have captured, let me just check in the end. Okay, so we have captured 5782 packets. Now we can store this file, save as, or save. You can select the particular format, in which format you want to store this file. So we'll use pcap. Okay, test.pcap. Now when I will click on save, it will save this file. You can see the file name also. Now I can file, open, here test is the network packet. Now you can share this file with anyone, or you can use this file for the further investigation. Now I'm just opening that file. You can see there's so many packets captured by this file, as the network packets we have already done live. So this network file can be further used if this contains any infection or malicious anomalies in the packet. But again, to check each network packets, you should know about the particular header. So if I'm going again to this statistics or protocol hierarchy, you can see there so many connections have been observed in this network packets. UDP, TCP, 98.7% of the packets, total captured packets, are from TCP packet, and only few percentage belongs to UDP. In UDP we have SHTP, DNS. In TCP we have TLS, NetBIOS, malformed packets, hypertext protocol, and data. Some packets which don't follow the RFC standards, Wireshark automatically provide you the visibility in those malformed packets. If I just click as I apply as a filter, you can see why Wireshark has marked this packet as a malformed. New fragment overlap old data, because fragmentation is again a concept of the IP layer, and if you are good in the protocols headers analysis, you should know that fragmentation are done by the machines or the router to fragment the packet, big packet, and a smaller number of packets. So in the line, when the packets, fragmented packets, will be received by the destination machine can rejoin those old packets. So now Wireshark had observed a new packet which are overlapping the other data. So might be it's another retransmission, or attacker try to evade from the security products by sending another packet, and IDS or IPS might allow this packet to pass through and destination machine if targeted is specifically for a particular operating system and it is might be an attack, then it can join with the legitimate packets and the payload will be delivered to the machine. Okay, the next question I can see is from the case. It is a free Splunk. Yeah, so because it is free Splunk is free for 60 days, and you can use the search and reporting application for you if you want to ingest logs. But there are different applications which you have to pay for that. That is enterprise security application, which used by the companies for to make the Splunk as a SIM solution. Anumla asked other question that if we have a basic SQL injection like 1 or 1 equal to, if we keep encoding this injection for 10 times or more than IDS, and IPS can detect or the attack will happen. Okay, this is depend upon the capabilities of the IDS and the rule, right? Now today's topic is just to understand the network packet, but if you will just going in another direction, that might be we will change the topic. I would request everyone to subscribe which we are watching this video or this session. Please ask the questions which are related to this video or to this content only. I can give you the answer. It depends upon the IDS and IPS, but attacker can try to encode multiple times the same string, so it can easily evade. But IDS and other security products can also have capabilities to decode the string and can get the actual threat and can detect and block that as well. Depend upon the configuration and how you are using your IDS on the encoded strings. But please, I would request everyone to ask the questions only related to this video. Okay. Now I'm removing this filter. You can see we also have captured some HTTP traffic. HTTP traffic are the unencrypted traffic which we can use to view the other connections also. So for example, let me just check in this. Okay, cool. So we can see this request actually sent to this URI. Now we are looking for that particular, okay, I think the same IP address. Okay, now we can correlate, because this is a correlation. When you are correlating one information with any other information, that means you're correlating and identifying and collecting more details. So we can see this is the HTTP packet with the JavaScript. If I'm not wrong, JavaScript object notation object is this. Okay, HTTP packets which are unencrypted, we can easily click on the follow and TCP stream. you can see the request and response if the packet are unencrypted. So we can see the request only very few information which is easily available and which is here. Let me click on follow HTTP stream. You can see the request and the response. We can see this information only because this information is not encrypted, and Wireshark can easily decode this information if the channel is unencrypted. In case if channel is encrypted, then you can also decode this information, but you require private key for that. Which I will show you in the next session maybe, or let's see if we have enough time in this session or this class, then I will show you how we can also store the private keys where we are visiting the websites and how we can see other information. Okay, the next comment is from the Mega, that we know it's easy to get the password from the captured UDP packets, but how can we do the same with TCP? Mega, first understand TCP and UDP are the protocols. Okay, packets, the password information you are talking about is based on the if channel is encrypted or not. If channel is unencrypted, that means channel is using HTTP or telnet type of services where you can see the username and passwords. But if channel is encrypted like Secure Shell or TLS or like HTTPS services, then you need the private keys to store and to give the information to the Wireshark, and Wireshark can decode those information accordingly to show you the content of that packet. Companies install some certificate in the different agent endpoints, so in any communication or the servers they can offload the HTTPS connections and can decrypt the information, so they can look for the malicious content in the application layer and can block the packets accordingly. And that I mentioned that if I will get today's time, I will show you how to decode this packet, because I don't want to change my content, but now we are talking about how we can identify anomalies in the bad malicious network packets. Okay, you can see this is the request. First understand this request, because when you are investigating to the network packet captures, you are good, again you should be good to be good understanding about different protocols, services, port. So you can see this is the get request sent by the client machine. You should know this request before. The request sent to this host by this application, and you can see the request URI. This is the response. You can see the response 200, that means okay. This is the get methods to access a particular website or URI. If it is a post, that means we are submitting something data to that website. This is get to get the information about this particular file present on the server. And we can see the date and time last modified the page and other information in that code. But if you will look in the details, what it has, okay, name server, development production, free trial expired. So our machine has sent some request which got in the response by the mail server that the request has been expired, or because it's a trial has been expired. This is information for you. It could be an attacker or attacker posting or accessing some malicious websites. We can see the response. What was the response from that website? But in our case, it's legitimate Amazon websites, and I'm aware about it, so we are just leaving it. If you are not aware, then just open this to perform further analysis based on the domain name by looking on the information about the ORS total, URL scan.io, URL void, the different online sandbox which you can use during your investigation to validate about the reputation of the IP address, reputation of domain name, how they execute the code on the machine. Okay. Now I have opened a CMD command prompt in the machine. I am changing the color to 0F. So I think now you can see the content. I'm clearing the screen by CLS command. So first we have opened the CMD, the command prompt, right? So attacker, when compromised in a machine or server, they try to access this shell like CMD, or in terms like when they access a compromised Linux machine, they try to access the shell to run execute commands. So if you are not, we can also run as an administrator with high privileges. Okay, now we are running this CMD with the administrator privileges. Now whatever we can type here will execute with the admin privileges. If attacker got access to this web shell or to this command prompt, they can use this to add an account, to get download a file, to execute an application for the enumerations about the user accounts, file shares, and other information. And all network packets captured, network connections can be captured with the network packets. So now let me just, if I'm giving an example and a simple scenario how attacker compromised a machine, and once the attacker compromised the machine, how quickly they are to add an account and delete an account. So if I want to add an account in the machine here now quickly, I can simply use the net user command and the username, for example SOC, and can get the password, anything, Vikram Hunt the hackers, and then /add. Then we have to give some complex password, because as per the policies it has, for example 123 or S3. No longer. Okay, let me just make it more complex thing, but it will be again for me as if it is STFG. Okay, so we have to, the password entered is longer than 14 characters. Okay, so now let me use very simple password again with complexity. Okay, welcome 974. Okay, again let me add the account. See, now we have added an account of name of the SOC, and the password for that account is Vikram @ and @3. So attacker with one command or a malware file with one command can enter, can create an account, can play with their machine as they want to play. They can add account, they can block your antivirus, they can stop your antivirus services, they can remove any application, they can install backdoor in your machine, they can open any port, they can communicate anything. Now clear the screen. So what we will do today, we have some network packet captures files, okay, which we will run against our IDS which we have installed as a SNORT IDS we have installed, and let's see how it generates signatures in the base of the signature match. So we have installed our signature SNORT in our CD C directory. CDC. SNORT. So we have in the SNORT directory, in the SNORT we have two informations which you should understand first. SNORT has a configuration files which used to load the SNORT to run the specific configuration set, which we have already present in the etc folder, and then we will run this SNORT from the bin directory cd bin. Now here we have already a SNORT directory and other packet capture files which we will use to see if the network packets have any signature match with our signatures in this SNORT. So when I run the command dir, that's showing me the information, the file present in the particular directory bin. You can see we have some files with pkap format, 1.pkap, 2.pkap, 4.pkap, 6.pkap, attack.pkap, attack 1.pkap, ismp.pkap, and other DLL files, dynamic link libraries files which is used by SNORT itself for running the SNORT properly, and one application snort.executable, which we will use to run our SNORT. Now I'm again clearing the screen. SNORT. First we have to run this SNORT. Okay, so if you are new to this SNORT, okay, if you are new, you don't know how to what syntax parameters you should use with this SNORT, then let me tell you, with SNORT the basic command, if you are new, if you have installed the SNORT, the basic is very installation. The installation is very free and rule is also free. You can download and install SNORT in your machine as well and can configure accordingly. If you will have any doubt, let me know, so I can also make a video or can give you another sessions on the SNORT installation and configuration. You can try by yourself. This is your considered as a homework for you guys to install SNORT and make it run in your machine. So SNORT, by first command which we can use generally when we enter the SNORT, to see what interface it has. So now you can see it's showing the different interfaces, which, because as we have run our Wireshark to a particular interface, we can also run this SNORT to see if any packet capture, if any signature triggers based on the traffic or content. I will show you also in this last session, when we end the session, I will show you how to also run this SNORT in real time scenario. In real time, when you are working with your laptop, you can run SNORT in the background to see if your machine is compromised or not. And we will also troubleshoot, because to understand this threat hunting, incident response and forensic, you should know how you can first identify the infection in your machine. If you are good in the investigation, analysis and skills, then you can only work with others. But first you have to be good with yourself, and then you can be with others' machine. If you don't know, even you don't know how to identify if your machine is compromised, then how can you be a good SOC analyst or good cybersecurity expert? Can we never, right? So I will show you, but just we discussed, as we mentioned, I will run some packet captures and then with the SNORT, and then see if any signature triggered or not. And then we also run this SNORT with the real-time network packets or network connections. So now I am running this SNORT. We have to define the first configuration file, which is present in the C directory, C SNORT etc snort-conf. We can use the argument -r and the packet capture name, for example 1.pcap, right? And we want the results output on the screen, so we are using -a in console. Now it's not loading different configurations files, rules. Then in the last it will show if that packet has any malicious behavior. Now we are comparing that network packet with our IDS to see if that packet has anything malicious which require attention. Why we are running with this SNORT with the packet capture? Because packet capture could have like thousands of different packets. To check everything, it's very sometimes in a short time it's difficult. So we are first checking with an IDS, and then we will look into the packet manually. So we can see the packet number, it shows the particular information about the packet. So the packet which we run against the SNORT, we can see total session is 104, UDP is 101, and other information about TCP segments, TCP gaps. Okay, cool. You can see more details about here. Ethernet packets are this, received analyzed packets are 2895, and IPv4 packet 575, ICMP packet 136. Now I would not tell you that what is ICMP. I'm expecting that you know ICMP very well. If you are learning network packet analysis and you are good in the SOC, these are the advanced concepts. And in my book and the hackers, I already mentioned everything about the different headers and protocols very well, and even in the SOC course. So if you don't know, then it will be much challenging for you to understand about each headers and packets. You don't know what is ICMP, you know what is TCP, UDP, how it works, what is the requirement for different headers, you might face difficulties to understand it. The prerequisite to understand the network packet analysis to first clear your concepts for different protocols, services and ports. So ICMP, I'm telling you again, it's just another simple protocol which is used for checking the connectivity and provides reliability when communicating over UDP protocol by giving error information. Okay, now we can see there are so many signature triggered. Now even I cannot go up because it is specific buffer length which can show only the number of limited lines. So I just want to, either I can export all these alerts generated by the SNORT in a specific log file, or I can use another command with another arguments -q, in which SNORT will run in the silent mode and will not show the verbose information with -q. Now SNORT will not show how many packets analyzed, checked or cross-checked with the signatures. It will show only the results. Let it run. We will wait for a few seconds. It will take some time because SNORT checking signatures against signature database with this packet capture to see if any threat matches in the content of the network packets. See, now SNORT completed the task and we can see there's so many signatures triggered. So if you look in the signatures, ICMP text successful, because we have a rule in our SNORT that any ICMP traffic identified in the real time of packet captures, it should trigger a signature with ICMP test. ICMP is generally used to check the connectivity. If any protocol is using ICMP, why? What is the purpose of the ICMP? It could be used for the host discovery attack or host mapping. We can see the connection for the ICMP between. So first understand the SNORT signature. This is a date, time, signature ID, signature name, priority, source IP, source port, destination IP, destination port. ICMP does not have any port. That means it is the reason it doesn't show any information over it. But in the down, if you come down, you can see the other signature, policy SMB version 1 protocol detection attempt. There's some signature which is classified as a potential corporate violation. You can see there is some specific IP address 73.10 which is communicating toward the SMB protocol over port 1069. To port 139. Okay, then we come down. Okay, SMB, again SMB overflow traffic observed from this IP, from this port to this IP to this port. What is this port 1069 is running on? We can check and we can identify if the machine is live and this packet was captured in the real time. But if it's a historical analysis you are doing, it's not possible for you to run the packet or to open the device and identify the process running with this port number. That is the reason companies do the forensics, memory forensics, to see which process was communicating on what port, so we can identify if there was any malware file was doing or if attempt by any legitimate or unauthorized application. And there We can also look for the signatures over the other security products or the logs generated at a particular time during the investigation, and can memory forensic will reveal those hidden artifacts which are not visible through network packets or device logs. Okay, other signature we can see ICMP. Okay, then other signature is consecutive TCP small segments exceeding thresholds. That means SNORT having signatures which are looking for the small segments, small packets per TCP, and if the size is exceeding that particular threshold. And I then again ICMP test. Okay, which this information, this threads which we have identified in our packet number 1. Now let me run the console, run this note with the real-time scenario, or let's consider another packet capture. Let me capture packet number 2. Now we are running our SNORT with the packet capture 2 to see if what other threads can be matched based on this signature database in the SNORT with the packet capture. And then we will browse manually in the packet capture with the Wireshark to see other informations which we can, oh my god, see how many signatures triggered in the PCAP2. It's again ICMP test and several other multiple products blankness ICMP, which is used for denial of service attempt. Because denial of service, that means DOS attempt. If you are targeting a machine by sending multiple packet with ICMP a protocol, that means you are taking the CPU and memory usage of that machine, and if a machine will keep try and responding to your packet on time, and that means that CPU and the memory usage of that machine and the rest machine will be increased, and then could also trigger or choke the network bandwidth, which could be in the cause of denial of service attempts or can stop the services running for the legitimate purpose. And we can also look for the other information available for this particular thread as per the documentation available in this note. Now if I come down again ICMP test, this generated this signature matches because of the particular type of traffic is not observed in this packet capture 2. And then again same type of traffic policy violation for the assembly over the port 445. In the previous packet it was on port number 137, I believe 135, sorry. Okay, again, so moreover the ICMP and the SMB protocol violations we have seen in those two packets. Now let me open these two packets in the Wireshark. Okay, now I'm opening those packet captures, open file, go to the C. Okay, let me see if those files in my history, open recent files, so many files, open C drive, and then we can look for the our SNORT, and then in our pin directory these packets we are stored here. So I'm opening this packet capture 1. Okay, so let me first open this file one. Okay, we open this file. You can see so many ARP requests also. When we were matching our packet capture with the SNORT database, we have seen the signatures was mostly over the SMB and on ICMP. But we can see this ARP request, mostly the ARP request I can see only in this packet capture, not ICMP. I'm coming down, down, down. Only this packet capture is full of ARP request. DNS, SMB, then again ARP. Let me go to the statistics, protocol hierarchy. You can see the different connections. Okay, 79%, more than 79% packet capture for the ARP. How it could be possible for a machine to generate this many high number of packet requests only for the ARP request? And it has total number of packets like 2895. That means 2895 packets captured, and out of which 2200 packets, more than that, it's only for the ARP request. Something bad. I can assume something bad happening, because ARP, if you don't know what is ARP protocol, then you should go to this course to understand about the ARP protocol. What is the purpose of the ARP protocol, why it is used for, why it communicates. So if we go back to see the purpose of the ARP request, this is just providing the information in simple terms. If I would say it's changing the ARP in simple terms, it will be like changing the MAC to IP or IP to MAC. Now let me just again go to the top of the packet captures. Okay, so this again we can see these different requests sent by this source MAC address, and these all are the broadcast packets. And if you are good, if you know what is ARP protocol, can you tell me where is the attacker IP, or what is the attacker IP here? Anyone can please mention in the comment section that what is this purpose of having so many ARP protocol? Can you guess what is about? Okay, Pritesh asked one question. Please explain WAF and DLP use cases. Pritesh, as initially I started the video, this session I mentioned that we will be more focused on only in network packet analysis. We will not divert the topic, but yeah, I will consider your point and will make a video on that shortly. Or maybe we can discuss in our other sessions. I will come and will show you, tell you about the different use cases, difference and the purpose. Or if we will have time in the end of session, might be we can consider this question to give you about these examples. Okay, so next is for the, is it important that only ICMP packet is used for DOS? No, Mega, it is not important only ICMP. It can be done by any packet, ID protocol, TCP, UDP, ICMP. You can use fragmented packets also, or you can use DNS packet as well. It depends what kind of the vulnerability you are targeting for. Can anyone tell me now what this ARP is doing here? Why are there so many requests? Tell me if you are suspecting this is could be legitimate ARP request or a malicious ARP request. Then I will tell you about my observation. I'm waiting for your comment, guys. Please mention, because it will not. There's no point if you don't know. I'm just about the ARP request, so I can guide you now. We are live, and I can help you to understand it well, right? So, tell me, what do you understand by the ARP, and why we are seeing so many ARP messages in this network packet? Deepak Singh mentioned in the comment that multicast or maybe broadcast request. It is clearly mentioned in the network packet. We can see it's a broadcast packet, but we just want to know why there are so many ARP requests. So I will tell you, if you will not help me to understand what it is, why this the presence of this so many ARP requests in this packet capture. Can anyone guess why there are so many ARP requests? Or it's another message? Tell me. Mention in the comment, guys, please. Mega, to have MAC flood. So MAC flood, what is the purpose of the MAC flood? I will wait for more 30 seconds and then I will reply in the answer. Deepak mentioned about the H ping. It's not about the ping packets, it's about the ARP request packet. Ping is different protocol. Okay, so guys, we have so many ARP requests here because if you will look in the information, because that's the reason I mentioned in the starting as well, you should be good in the basics network protocols before jumping off other things, because now you can first you should know what is ARP request, what is the purpose. Okay, Dalveer mentioned for ARP poisoning. Okay, what is ARP poisoning attack, what is MAC flood attack, why it happens, what is the requirement. You should know all about these different attacks, the purpose, because if you will not be clear on the basics concept, you cannot investigate the real world scenarios. You can see, and you should know what different type of the ARP messages sent by a machine. So if you are good, then you can see these all are the ARP request messages. ARP request message sent by a source machine to the destination or to the broadcast network that I want to communicate to this IP. What is the MAC address? Okay, so if they are not sure what is the MAC address of that device, machine generates ARP request message to the broadcast, and which IP address, if that IP address is in the network, that IP address reply with the ARP response packet that this MAC this IP belongs to me and my MAC address is this. So the source machine can use that MAC address, forward that packet in the network. In simple terms, ARP is used for as a resolution for MAC to IP and IP to MAC. So you can see the source is same, destination is broadcast, ARP protocol, and information showing the information about the other different IP addresses: 8, 9, 15, 3, 12, 10, 17, 14, 11, 12, 13, 16. So many IP addresses are there. So if we go down, you can see it's gradually increasing, like 8, 9, 10, 11, 12, 13, 14, 16, 17, 18. Where is 18? 18, 19, 20, 21. So it's increasing. Let's see, 142 till 168, 75, 76, then 85. So we can see this IP 192.168.73.135 is belongs to a machine or device which sending a request to a complete range of a 192.168.73 dot star to know what are the devices are exist in the network. That could be a health check, but ARP, why machine use ARP request? They can use an SNMP protocol, they can use ICMP protocol to check the ping request. But again, now what I can suspect, either this is health check of devices if is available in the machine, or more possibilities are for attack. And attack name, can anyone give me the attack name for this type of traffic? MAC flood. We are not flooding MAC address. We are mega understand, when we perform ARP poisoning or we are doing a flood for the MAC address attack, that means we are telling everyone that this MAC address is mine, but you can see the source MAC address is the same and the destination IP address are different. This is if the MAC address are changed, or we can see if the same source IP have different MAC address, that could be a reason of ARP poisoning. That means this IP have MAC address already, but trying to lure the user to send the a device to send the packet of which designed to designate to other machine but send to the attacker machine. But in this case, attacker want to know the MAC addresses of other devices. Okay, then we can look for the other questions. Okay, ARP is basically used to address resolution done in MAC, so ARP request can make switch to hub and make the flood. Okay, the same thing. Hema Sagar, hi Chandu. There is no Chandu Hema. I think you are either on a wrong session or you are misguiding us. Please ask your questions if you have a doubt. Otherwise, I would request you to leave this channel. Mega. A purpose of MAC flood will be so that IDS would not identify which is the MAC address of the LAN and which is the offsite. Okay, again, Mega, let me give you the killer visibility again. Okay, MAC address assigned to a machine and IP address also sent to a machine. MAC is a physical address and IP is a logical address, right? In switches or hub is already violated the policy of security. If you're sending any packet to the hub will forward the packet to the all devices. Switch is an intelligent device which use the CAM table for forwarding the packet from one device to another packet based on the MAC address. Now, other machines or attackers target switches to make the switch behave as a hub. So, attacker connected with the switch with other port can listen to all traffic. For that, they do this flooding or ARP poisoning attack. They tell the switch that I am owning this MAC addresses. So any information coming to this MAC address, send it to me. And switch what it does, an attacker what does, attacker send the different MAC address or particular MAC address information to the other machine. Switch will forward all the requests which were need to be sent to the other machine, but switch forwarding to the attacker machine because we have operated the CAM table or flooded the MAC table or CAM table, we can say. But in this scenario, attacker is performing an attack which is called host discovery attack. Attacker want to know if this machine is online in the network or not. Simple. If I want to check the connectivity in the network, if I've compromised a machine, my second objective is to find the other connected machine in the network. If attacker have compromised your network, attacker could send this ARP request or ICMP, because you can see our IDS had generated a signature for the ICMP, but did it generate signature for the ARP request? No, because attacker aware that what kind of the security product you are using and what kind of the signature capabilities you are looking for. That is the reason we can see IDS generated the signature for the ICMP but not for the ARP. See, the benefits of manual analysis. We had compared our network packet with the IDS to see what threats exist. But when we are reviewing the network packet manually, we can see other hidden artifacts. The attacker with this IP address 192.168.73.135, we can confirm this is the IP address of an attacker machine or pen testing team. If you having a team which done a pen testing in your network, then we can confirm internally. So we can see so many request host discovery attack performed by this attacker IP to see. And don't forget about the signature triggered by the IDS. It triggered for the signature for the ICMP as well. So we can also see attacker if tried also to run a scan with ICMP. Okay, now see, let's another difference. Now we are using a display filter ICMP. You can see request reply. Okay, request, and now we know the IP address of the attacker, right? So let it filter with the IP address of the attacker. We can, if you are not good that with the display filter, you can click here in the details, can go to the particular specific header information, source IP. Okay, if we click on this, select as apply as a filter, selected, and then you can select on ICMP as well. For example, protocol, right click, apply as a filter, and selected. We are putting two conditions. So it used IP protocol 1 because in IP version 4 the protocol number for the ICMP is 1, and we can use, instead of source, we can use it as IP header. Either it is source or destination, we can see. But if we'll look for the source only, you can see request. Let me just control again, go to the ARP request to confirm the IP address of the attacker. 73.135 is the attacker IP address. Okay, now we are looking in the ICMP packets. Okay, ICMP packet, you can see this IP send a different request to 5 to 110 129 254, come down and targeted on port as well. Let me check the port details. Can anyone tell me why there is no information about the port? Anyone tell me why we cannot see the port details in this packet, and in the error message we can see this is saying port unreachable. This session is I want to be it more interactive so you can understand and I can help you to guide you, right? If you will be on silent and you will not ask anything, you will not raise your doubts or questions, we will not able to understand it properly, and there is no point of wasting your time. So if you have any doubt, if you have any questions, if I can help you, please let me know why there is no port informations available. Sayed mentioned in the comment because ICMP based on the echo request and echo reply. Okay, let other people also reply, then I will give you the answer. Sayed, for this I will wait for 30 seconds now for your reply, guys. Please mention in the comment why there is no port information. Okay, so guys, first, as I mentioned initially as well, that if you want to investigate network packets, then you should know about each protocol, about each port, services, purpose, headers, other information. Let me clear your doubt, Sayed, here for the ICMP. ICMP is a protocol, a communication protocol we can say, or it's supporting protocol which used to check the connectivity, and it also used with the UDP for delivering the error messages. In the cases where you are sending packet for UDP packet and the packet is not reachable because port is closed, or if the machine is unreachable, that the destination machine will reply with the ICMP message. And you mentioned that ICMP is based only on echo request and echo reply. No, this is your homework to check how many other type and code available for the ICMP protocol, because ICMP works in different types and codes, and different types and codes are different message information, contains different message information. The echo request and echo reply is just only two types of messages, but ICMP generates different types of other messages which are very useful in the investigation, in the response, in the analysis, or for the attacker as well. So to identify the attacker, we can look, because this is the response packet, because this is a response by the destination machine to the attacker machine that port is unreachable. Now let me just look for the details between these two communication. Let's see. IP dot dest 192.168.73.10. Okay, so let me just now do one more thing quickly. On this IP address, where is the IP address? Destination source. Apply as a filter, select it. (135) and UDP. Let me click on the UDP, selected. Now we are putting a filter, and so you can see the connections from the attacker IP address toward the UDP protocol, which is the protocol number 17 for the UDP. Now we can look for the UDP packets. See, so let's see now this. This is the port number for the UDP protocol, and you can see this information only in the response. That is the reason ICMP first size is bigger than the UDP packet, and it contains the information about the initial request as well. So you can see the request source port and destination port for the UDP and this port, and the port is unreachable. That machine is does not having the port running. Okay, so now we have seen the other domain request. Okay, so you are now unclear on the part where ICMP contain the information about the UDP protocol and why it is used for. So this is second attempt. Now let me look for other information. DNS. You can see this DNS 1 quad A PTR records request. Again, if you are investigating the network packets, you should go with the DNS protocol. What is the purpose? What it is used for? So now let me capture. So we can see this is the request messages. Request messages for the record A, quad record A, PTR records, NS records. It's for name server. So why a machine? Why a machine will generate different record types? What is the purpose? If my machine want to communicate, it can send a request for a single A for 5004 address. If I want to open a Facebook server, why a machine would request for the name server? Can anyone tell me? What is the requirement for this machine? We know this is the attacker IP. But what attacker want to achieve by sending the request for different domain servers, domain records? I think we are running out of time also. So this will be the last topic and we will continue our Wireshark analysis in our next session. Maybe tomorrow, or I will update you guys. But tell me first before ending the session, why machine targeting different DNS records? Anyone? I will wait for 30 seconds and then I will tell you the answer. Anyone knows why a machine sending different DNS records? What is the purpose of sending the request in a server? No one? Syed mentioned to get the IP of the domain. Right. But why a machine require to know the IP address for the name server, for PTR records, for the domain IP? Understand, it's request obvious. But why a machine will generating a record type for the NS, that is for name server? Okay, when attacker want to attack on a company, then attacker first target on the DNS server of that company to know the other domain names and IP address used by the company actively. So instead of targeting blindly on the IP addresses, attacker can know the IP addresses of and the domain name of the active machine in the network. So attacker can target the open ports and then vulnerabilities and then can exploit the existing weakness to take advantage by delivering the malware. So name server targeting by the attacker, the purpose only to know about the active online machines in the network. This is the easy way for the attacker to get these by targeting the domain name server of that company. So if you are seeing different DNS records targeting sending by an IP address to your company, then you can suspect that might be attacker is active now and collecting the information. So these all phases are considered as a information gathering phase. And now I think today I have done a lot of things today about different protocols, and also my battery for this machine getting killed. So let me just close the session. So before closing the session off, I would request if you have any other question or doubt, and we'll continue from here in our next class. Whenever it will be, maybe tomorrow or day after tomorrow. We can have time, we can have arrange the session. But tell me if you have any questions or doubt, so I can help you to get the answer. So for the Pritesh, we asked about some use case name. Let me go and back to that question now quickly. Okay, Pritesh has asked about please example WAF and DLP use cases. Pritesh, WAF is used to identify an attacks targeting the web application. Simply, I will say simple in terms. I would suggest the use case, the basic use case could be like SQL injection, course scripting attack, tactic reversal attack, command injection attack. These are different attacks which detected by the WAF. But DLP, data loss prevention, are used by the companies to prevent any loss of data or which is classified as confidential, internal or classified. So DLP product used by the companies to tag the data with the particular keywords which they monitor, and which if users are uploading any data from the internal company to outside cloud or outside their Gmail or any other outlooks. So DLP use case would be more about to focus about the data loss or the stealing of data from internal to external, or exfiltration it used to trigger the use case which we can validate the activity with the user to confirm if what was an exfiltration attempt or was a legitimate activity for business purpose. Okay, any other question guys do you have for me before we close the session off? Any questions, any doubts guys do you have? Please feel free before my laptop switched off. Okay, thank you then guys, thank you everyone for joining the session. We are expecting it to complete by today, but it took a long time than expected, what I expected, because it was more about to tell you first, understand about the protocols, the headers, information, the purpose, then only we can analyze the packets, right? So might be we can finish off this investigation analysis of the network packet in our next class or session. Thank you for joining all you today. Have a great day guys. Bye bye. Take care.